Unless you don't like Oreos.
I mean, yeah, like if someone said, do you want sardines or do you want sardines and Oreos? Clearly the one with Oreos is going to be better. Now, I don't think I'd crush up the Oreos and mix them with the sardines, but even if you did that, I still think the Oreo one would be a little bit better than plain sardines.
What's about like pickles and Oreos?
Oh, pickles and Oreos are good.
She's got it.
Make you sick. I have.
Pickles and Oreos.
So Peyton won't eat like just a cheese stick, but she's like, pickles and Oreos is where it's at.
Okay, so today I'm going to teach you how to find the area of a sector of a circle. We've been finding circumference of a sector of a circle, which is just a fancy way, or a not fancy way, I guess, of saying arc length. Today we're going to figure out the area of the sector, which is like if this was a pie and I cut out a slice of pie, how much pie would I have? Hey, speaking of pie, how do I find the area of an entire circle? Pi r squared. Circumference was 2 pi r. Pi r squared is close to that. We've still got a 2 and a pi and an r. Just now the 2 is an exponent instead of a coefficient. Thank you. So we're not going to spend even 1 second of your life doing just the area of a circle, because you should have learned that years ago. And even if you didn't learn it years ago, it's still pretty simple. You just get the radius and do some multiplication. Here's what we're going to do.
That's cool.
I've got a fountain with a circular base and a radius of 6 feet. So a circular fountain, 6-foot radius. And around that fountain, I put a circular path 2 feet wide so that people can walk around the fountain and look at water or whatever people use fountains for. Here's my question. I want to pave that path using solid gold bricks that have been carted down from a gold mine on the top of the Himalayas. How much area am I going to need to cover with my solid gold bricks that were carted down from a gold mine on the top of the Himalayas? So what I'm really saying is, what's the area of this piece? Very good. So Emily's saying in words what our strategy is going to be. So let's go ahead and write it out just in English. Step 1, find the area of the entire circle. Step 2 is going to be find the area of the fountain. And step 3, profit. So subtract the answer from step 2 from the answer, using the word from too much, the answer of number 2 from the answer of number 1. Good. We will do it piecemeal, which is your second word for the day. SAT word, piecemeal. A little bit at a time, piece by piece, piecemeal. So step 1, find the area of the entire circle. The penultimate step, find the area of fountain. And the final step is to subtract, because I can't spell, subtract the answer. Third word of the day, penultimate, next to last. Feels like an SAT day. Okay, step number 1. Area of the entire circle. Eight. Why 8? Exactly right. The radius of the fountain is 6. The path is 2. So the entire thing together is 6 plus 2. So I'm going to write it out like that. You don't have to write it out. You can just do 8. But I'm going to write out that it's 6 plus 2 squared so that we know where the 8 came from. So that's going to be 64 pi. And I'm just going to leave it as 64 pi for now. I will eventually have to round the answer, and that's fine. But I'm going to round the answer as my last step. I want to keep the exact number right up till the end. Exactly right. Mm-hmm. And my unit is going to be close, square feet, because it's area. Cool. Feet squared or square feet, doesn't matter. However you want to say it. It'd be tough to find shoes that fit. Oh, although actually, you could buy 2 pairs of shoes, give the shoes away, and then use the boxes. They probably wouldn't last very long. You wouldn't be able to take them outside when it was raining. Okay, next step, the area of the fountain. There we go. The fountain just has an area of 6 feet. Fountain. I'm Norwegian, that's how my people say it. What do you mean, your people? And the unit there, also area, so square feet or feet squared.
So what you're saying is your part.
Yep. Step 3, big circle minus little circle. So the area of the path is going to be exactly 64 pi minus 36 pi, which is 28 pi square feet. So if I send my people up to the top of the Himalayas to mine the gold bricks, and they said, all right, so how much area are you going to need to fill up with these gold bricks? I'd say, why, 28 pi square feet, my good sir. And they would say, you dummy, what does that even mean? So then I would give them probably an approximate answer. Go to your calculator and type in 28 pi, or 28 times 3.14159.
87.96.
Good. So I'd say it's approximately 87.96 square feet. I might tell them, you know what? Just go ahead and get 88 feet so that in case I make a mistake, got a tiny little bit of extra. Or if you had to pay for it, you might complain. Depending on how difficult you thought the project was going to be, how often you thought you would make mistakes, like carving the gold bricks into that curve shape, you might even say 90, 95, 100. You might want some extras if you're not a very... Just double it. I probably wouldn't pay double the amount. If I was that bad at it, where I'm like, I'm definitely going to completely mess everything up one time, I'd probably just get somebody else to do the project. But you might want to go, depending on how expensive the materials are, you might want a little bit more. Just what everybody wants, a whole bunch of end tables.
You can make other things too.
Well, I could make lots of things, but you specifically said a lot of end tables, which is really interesting. So what we just did was we found a piece of a circle. If you consider the giant circle with a radius of 8 to be the circle, then finding the little ring around the outside was like finding a piece of the circle. That's what we do when we find a sector. A sector is a piece of the circle. However, a sector is a little bit easier than what we just did, because instead of having to figure out 2 circles and then subtract them, if we want to figure out the area of a sector, we have a formula, a pretty simple formula, that will allow us to just go straight to the area. So this sector that we're going to find here is the sector that has a central angle of 135 degrees. Oh, it's a B, but a B does look like a squished together 13. So if you think 13 is unlucky, then you would also think the letter B was unlucky. It's guilty by association. Okay. Now I'll give you a hint. The process for finding sector area uses one of the same strategies that we used for finding arc length. So if you had to guess what our strategy is going to be, what would you say? Mm-hmm. You can solve these using radians, and we will later, but for right now, we'll stick with degrees.
Are we gonna do like the C? Are we gonna try to find the circumference first?
No, I don't need circumference. I just need area. I don't want to find the area of the whole circle, because I don't want the whole circle. I will only want part of the circle. How much of the circle do I want to know the area of? Which is how much of the circle? What's the fraction?
135/360.
Very good. So how much of the circle is a sector with a central angle of 135? And Emily gave us the fraction. It's 135/360. It probably can be simplified, but since we're going to do this on the calculator, who cares? 135/360. That's how much of the circle we want to know the area of. So then what? We multiply by the area of the whole circle, pi r in this case is 16 squared. If I wanted the exact answer, I would type this into the calculator with everything except for the pi. So 135/360 would be 3/8 times 16 squared, and 16 squared, of course, is 256.
96.
No, 256.
No, I'm saying I got the answer was 96.
Oh, okay. That'd be 32 times 3 is 96. Good. And then I'll just put the pi on there. Pi. The problem didn't actually give me units. Like it didn't say if the 16 was inches, feet, whatever. So I'm just going to say square units, since I don't know what the units are.
Wait, why are you multiplying it by 256?
Because that's what 16 squared is. Told you kids, memorize those squares up to 25. Save yourself a lot of time. Invest up front with memorizing squares to save time later.
Until we graduate.
Mm-hmm.
But it's still cool to know.
So Peyton suggested radians. That's a great idea.
Sorry, you heard us like this.
Well, it's not like we weren't going to do radians until she said it. I was going to skip radians, but since you asked for it.
I'm sorry.
Let's say it's 2.2 radians. And we want to find essentially the same sector area. This piece right here that we're given the measure before. It would be possible for us to find the area of the other sector, but it's just unnecessary amount of work because you just take the whole circle and subtract the angle measurement you were given.
So rad.
Point two rad. Now, believe it or not, the process here is exactly the same as it was when we used degrees. How much of the circle do I want to find the area of? No, because 2.2 is radians and 360 is degrees.
I don't know how many radians are in this.
I just told you that like 2 or 3 days ago. How could you not remember? How many radians are in a circle? How could there be 2 radians in a circle if that sector is 2.2?
Is there 6? There's an 8. There's a 12.
Looking at my notes.
Good idea.
2 pi radians.
2 pi radians. So the whole circle has 2 pi radians. So I would take, instead of 2.2 out of 3. Yes, you did. And that was not correct. Christian said 6.5. That was also not correct. You gave me lots and lots of incorrect answers, and I appreciate them. Multiplied by pi r squared. At least we were trying. You were just shouting random numbers, some of which did not even make sense. Now enter this as yet another reason why radians are cool. Our answer is not going to have pi in it. Pi in the top, pi in the bottom. They cancel. 2.2 divided by 2 is also pretty easy. That's 1.1. And 8 squared is 64. So when the smoke clears, I'm going to have 1.1 times 64. 1/10 of 64 is 6.4, and 64 plus 6.4 is 70.4. We were not given units, so again, we will say units squared. And that's the way, I like it. Come on, you guys know the words? I hope, because the only part I know is that's the way I like it.
I feel like the chair squeaking made it worse.
That's the way I like it. That's a perfect circle. I'll try.
Yeah, that's better. That's a lot better.
Well, they were both perfect, so I don't think one is better than the other.
This is definitely better than the last one.
I think perhaps you should get your eyesight checked. My circles are always perfectly round.
Looks like an egg.
Eggs are perfectly round, are they not?
This is the opportunity to say you. I wasn't talking about you specifically, Kate. I'm just saying that's a great thing you said.
I don't mean to be rude. You look like an egg. A brown egg. You look like a brown egg.
What?
With a crack in it, the kind that nobody wants. So they open up the package in the store and they see that it's a brown egg with a crack and they put it back. No offense.
Yeah,
Khalil was like,
you look like a foot.
and he called me, Emily, and Ellie
Four
four eyes.
eyes, even though the kid has glasses.
Plus,
So he insulted himself.
plus, if anything, the group of 3 of you would be like 12 eyes. That's just bad math.
And he said it wrong. He used it wrong. He goes, "Wow, all y'all 4 eyes."
All y'all 4 eyes. So y'all is a contraction of you all. So he said all you all 4 eyes. Can't wait till I get to teach that kid English. Okay, here we go. So How much of the circle do I want to find the area of?
3 pi over 4, 2 pi.
Yes. So it's a fraction within a fraction, or a fracception.
Wait, that's not what that's actually.
I'm pretty sure that's what it's called.
Are you sure? Because you say many things that
Are 100% accurate? Yes, yes, I do. And this is one of them. Fracception, final answer. Okay, multiplied by
Oh, 5 r squared. No, 5
pi times 5 squared. Now, unfortunately, our answer here is going to have pi in it because we have 3 pi's in this problem. 2 of them will cancel, but alas, one of them will not. It doesn't matter which pi's you cancel. The real pi is the friends we made along the
you
way.
can't have two.
So you can cancel this pi and this pi, that's fine. Or you can cancel this pi and this pi. Regardless, the pi on the 2 pi is gone. And then I'm probably not gonna be able to do this all at once, but we can go ahead and do this as 25. So then after that, we end up with 3 pi over 4 divided by 2 times 25. So the 3 pi over 4 divided by 2 is clearly a problem just because it looks weird. But dividing by 2 is the same thing as multiplying by 1/2. So I could do 3 pi over 4 multiplied by 1/2 multiplied by 25. And Peyton said this is 3/8, and she's right. 3/4 times 1/2 is indeed 3/8. So we have 3 pi over 8 multiplied by 25.
75 eighths.
Yeah, 3 times 25 is 75. So we could just say 75 pi over 8 square units. If I wanted the exact answer, which I don't, but if I wanted the exact answer, I would type into my calculator 75 divided by 8 times pi, or 75 times pi divided by 8.
See, this would be what would be funny to pave in gold bricks. So then I need 75 pi divided by 8 squared.
Square units.
Not even.
And not giving them the units would be the least of their problems. 75 pi over 8 miles.
Oh gosh.
It's a very long pathway.
29.45.
29.45, what? Is that what it is? When you multiply, oh, okay. 29.45 then would be the approximate answer. I didn't even figure that out, but sure. Sure, that sounds reasonable. If we wanted the approximate answer. Yeah, I mean, sometimes we want both.
Like if you're paving stuff.
If I want like a super accurate answer, like if it's really important to me that I get it exactly right, I would use the pi answer. And if I'm like, we'll just ballpark it. Like if I'm really paving a walkway around a fountain, it's okay if it's like 29 and a half. Like I got a little bit of extra brick left over, that's fine. But if I'm like launching a satellite to Neptune, a rounding error over that distance means I could miss my target completely just by rounding too
Or, like,
much.
hit something else and walk up.
Probably hit nothing else because space is mostly empty. Probably just off into the darkness until the heat death of the universe. But
And then there you go, all of your hard work and all the money from that satellite.
yeah, when you think about it, it's kind of incredible how accurate our satellite launches are, that they can get that close to planets. That's some,
They must be very stressful.
they're very good at math, and they don't round. They don't round this much.
Do you think you would do that? Like if you had the option, would you?
I think Peyton's right. It would be really stressful because it's literally billions of dollars that could be completely wasted if you like forget to carry the one or something. Very stressful job.
Who was that one? There's
when she did all the calculations with the first man, American man.
Was that Hidden Figures?
That was a great movie.
Does anybody have any questions about area of sectors using degrees or radians or the power of love?